Tonight, I'm going to be talking about the tech behind a design system that scales. I'm going to be talking about what are some of the things that actually make design systems scalable by nature, and also some of the tech choices that we made with scalability in mind. So, yeah, as Robin said, my name is Monica, obviously, that hasn't changed. And I'm the lead front-end engineer at SumUp, a company based here in Berlin. And this is a little bit about where we're going tonight. So first things first, I'm going to start with a use case. This is going to be a story from my time at SumUp that maybe sounds a little bit familiar to you and might signal that you have some problems that a design system might help you with. I'm going to talk about what a design system is, in case you're not using one or haven't really explored this topic yet. I'm also going to talk about what some of the challenges were that we had and how we set up our design system to actually address those. And finally, I'll just quickly show you actually what we built, how we took all of this theory and planning and actually made it into something that we have in production today and has saved us a lot of time and helped make our interface more scalable and more consistent. So, first things first, I'm going to give you some context about why scalability even matters, because of course it's not the case that absolutely everybody is thinking about the same kind of scalability. So to give you some idea, so the company that I'm working for is making this device. Maybe you have used it somewhere to pay for your coffee, get a haircut, buy a taxi ride. And what we do is we make hardware and software that basically enables small businesses to accept card payments super easy and without a long-term contract. So they can just go online, get this device, and get started. But what you might not know, even if you have seen this out in the wild, is that we've been around for about 5 years now. And in the last year, we've grown from 400 people to 800 people working for us. And we're projecting this year to reach over 1,000. So the sheer scale is getting pretty bananas. And on top of this, we also recently doubled our global footprint from 16 countries to over 30 countries that we're operating in. So you can probably imagine that as you add every new language, every new currency, every new business rule for each country, the complexity just gets crazy. And on top of this, we're not just making this device, right? We have web apps, mobile apps, and tons of different software products. So thinking about this on a big scale, there's really a lot going on. And at some point, we really had to think, okay, how are we going to do this going forward when we're really growing at this size? So from that kind of broad perspective, I want to drill down into a use case that might sound familiar to you. So here's a story that happened between me and my coworker named Felix. He was working on a React component that was going to accept a certain amount of money, right? Some amount of money you want to charge somebody else when their card is not present. And he was working on this input. It has to handle, as I said, a whole bunch of currencies. The formatting is really funny in every single different country and a locale combination. But even as he was telling me this, I was like, wait a minute, what are you doing? And he's like, yeah, there's so many edge cases, browsers, inputs, like my life is getting hard. QA is giving me a hard time. It's just not passing. And I was like, wait a second though. Like, I already built this. This is in production. It's been tested. What do you mean you are working on a currency input that's probably taking you 2 weeks to make absolutely perfect? So as you can imagine, he was like, you have to be kidding me that I'm spending all my time on this and actually it's already a solved problem. So what we found is that we actually had 2 currency inputs in our app now. So one of them is on one page that accepts payments online. And the other one is for issuing refunds. They were done by different designers and obviously implemented by 2 different developers. And you can see also they're not the same. And that creates a bit of a problem because if our user is using one, then they go to the other experience and suddenly the exact same interaction is different. Why should we force them to learn to do the same thing twice? And the funny part about this is that me and this developer were sitting next to each other, right? So it's just, yeah, here we are, talking about some code, right? And what happened is that we're working on different product delivery teams. So at some point, when you're working in a code base that gets really complex, has a lot of business rules, and you're working in parallel streams, it's just not possible anymore that every developer knows every single corner of the application. And this is what we were running into. Now, imagine this. As I said, we're growing a lot. We have engineering teams in 3 countries and 3 time zones. And the size of our engineering team has been roughly doubling over every 12 months. So this presented a question to us. How can we scale the team and the product offering while actually increasing developer efficiency and providing a consistent user experience? Because if everybody's just developing the same things, then you're not really actually increasing your efficiency and accelerating your efficiency. You're just kind of growing at the same pace. And to answer this question, we realized that we needed to take a more systematic approach. Specifically, that a design system was going to help us with some of these problems. So I really like this quote from the Envision blog, which says, design system is a collection of reusable components with clear standards that can be assembled together to build any number of applications. So with this, let's look at some of the smaller bits that make up a design system. So first things first, you have the ideas, right? You have, how do I want to communicate with my end user? How do I want things to look, the shapes, how do I want it to feel? And then you have the stuff that us designers and developers create. You have the artifacts, the manifestation of these ideas. And when you bring these things together into a single unit, you end up with a design system. So something where the ideas and the artifacts that you create as a result can evolve together over time. And there are a few ways that a design system, by its nature, is going to help you when you're thinking about scaling. So the first, perhaps most obvious one, is that when you have a central place for all your components, you're going to stop solving solved problems. You're not going to spend 2 weeks making something that someone else made, or in our case, you're not going to spend more time making localizable date pickers or all the other complicated stuff that you only ever want to solve once. Then, of course, when it comes to documentation, as the team gets bigger and bigger, it's not to say that you can spend the same amount of time with absolutely everybody. And the fact of the matter is that the team that we have is distributed. So everybody is either at lunch or they just went home or something like this. So having documentation that helps people solve their own problems also makes teams more independent and more efficient. We also have tools, right? So these tools are going to help us work more efficiently by creating a single source of truth. So instead of wondering, okay, which is the latest sketch file I need to open to find my design, I know that the one source of truth is in my component library, written in real code. And finally, a design system also needs to come with a process. So some companies are really lucky. They have a dedicated team working on the design system. There's 10 of them, and they are going to incorporate every change request. But most of us are probably not in that luxurious situation, so we need to find a way to accept contributions and keep the quality high. And this is also part of a design system as well. So next I want to show you what some of the specific challenges that we had in terms of keeping the design system scalable and how we solve them. So to start, as I said, people, right? We're growing the team quite a bit, and we want to make sure that our design system is built to handle contributions from a ton of different people. We also have a lot more products that we're building. As things are moving along, we know we want to offer new products, completely greenfield products, but at the same time, we're a company that was founded more than 5 years ago. So it's not that we have the most beautiful green pasture of React code. We have stuff that was built when there were different trends, let's say, in what was cool and in the tech universe. So we have to support that. We can't just ignore them. And finally, processes. As more and more teams work in parallel, we have to make sure that we're going to be keeping them in mind when we create this design system. So here are each of the solutions that we found, and I'm going to talk about each of them a little bit more. So when it comes to people, we wanted to make them efficient, and we did this by creating a component library workbench and documentation that's embedded inside this workbench. So that way you don't have to actually leave the code that you're working on in order to learn how other components work. We also created products based around theming. So we know that our different products are going to maybe need to look different for different markets, and we built theming in from the beginning. But we're also keeping in mind that our tech stack is not just React by making sure that we're going to be able to actually extract all of our CSS later for simpler projects. And finally, when it comes to the processes, we have to consider everything that we did when setting up the project for scaling and consider all of the teams that are going to be contributing and how we can get them up to speed quickly. And we do this through automating the documentation process and putting in some special considerations for how the tests are going to be run to make sure that all the cool stuff that we're doing doesn't break, as a lot of other people are working on it. But just briefly, before going into all of these solutions, I want to talk about why we picked React. Because when you're making a design system, people are often really hesitant to choose a technology like, should I really do React? Design system is for the future, you know? What if React's not cool in the future? And I already picked React, and then I have to convince everybody that I need to rewrite it. You know, this is a really hard choice. So to look at how we got to the point of choosing React, I want to go through a brief history of web development. So not so long ago, I was talking to a guy who'd worked with jQuery for like the last 10 years, and he put it to me this way: Monica, HTML and JavaScript is like ice cream and pizza. They're perfectly good on their own, and you're asking me to mix them together. Why would you do that? And you know, he's right. For a long time, this is exactly how we thought of our separation of concerns, right? We thought our structure should be separate, behavior should be separate, design should be separate, and that made us feel pretty good. The reality was that actually this got really out of control, right? We had massive templates. We had JavaScript that was changing things all over the page. You couldn't track where it was coming from. You have CSS that, small changes can have massive effects. And the real problem here is that we were really relying on these global names to connect all these different bits together. So if you messed up your global name or you needed to rename it, refactoring was quite a problem. And in the end, our theoretical encapsulation didn't give us what it kind of promised. So what we really like about React is the fact that it encapsulates structure, behavior, and design all together. And this is exactly what you want when you have a design system, because it's not just about how it looks, but also about how it works. And I should also add here that we tried a CSS-only design system type thing. And we had a lot of problems because it left too much to the imagination for how you could actually use these CSS classes. So this really actually enforces consistency and brings together the behavior and the design in a way that's kind of harder to screw up. So yeah, if you're thinking about why using React, this is some of our reasons, and I'll talk a little later about how we try to keep ourselves loosely coupled to React. So let's talk about people, what we do for the people. So a lot of you are probably familiar with Storybook, but if you're not, what it gives you is this component library workbench. So you have your source code, your documentation, developer preview. You basically get to create your components in isolation, separated from your app. And what we also really love is that with documentation, you can extract the props and the prop types of everything that is in your components, so people can really easily browse this, and it takes very little extra effort from just developing the components in the first place. And this seems pretty simple, but actually the effect is quite powerful. So the first thing is that it gives us a productive developer experience. And I don't know about you if you're working in the most perfect React app in the world, but some of us are integrating React apps into legacy apps. We're going through rewrites. We want to use React for just one small part. And it can mean that that app, the host app you're working in, doesn't have all of the most modern tooling. It might not have hot reloading. It might not have the fastest load time, but at least in your development environment, you're going to have something really efficient. The next thing, which I think is the most important perhaps, is that it keeps our UI components free of application logic. So when we're thinking about reusability, this is really, really critical. So what can often happen when you're creating components inside your app, even if you're trying to make them reusable, it's really easy to bind them to the context that they're being used in. So what happens is that not only is your UI component not reusable in a different application altogether, but it might not even be reusable in the same application itself because you bound it together to the context it's being used in. And using a tool like Storybook actually just forces you to think completely free of application logic. And this is really powerful when it comes to building reusability in from the beginning. And finally, we solve the two components problem, the two currency input problem, by making components discoverable. Because if a developer is able to find a component that's tested, it's used in production, and has documentation, they have literally no reason not to use it. And this is obviously a lot more efficient when you make things discoverable. Next, let's talk about scaling a design system for products. And I think this is one of the more like technical bits, but hopefully also more interesting. So how do we do this? First things first is that, yeah, we have a set brand, but it's not to say that every single place we're using this, it looks the same. So here, for example, you have our US website, and you have our website in Chile, where we are partnering with the National Bank, and we go under a different name, and we have different theming colors. So if you have ever implemented themes in CSS, you might know that this can be really painful. You start to mirror the DOM. You need oftentimes some kind of class on the body in order to make the theme do what you want. You have to kind of bend it to your will. It's not so nice. So how can we actually build this in without using a CSS solution that's going to make us suffer? So for this, we're using Emotion as a CSS and JS solution, but obviously there are a lot of others. And how does this work? If you're not familiar with this approach, essentially what happens is that the theme, which is just a plain JavaScript object, can be exposed through context to each of these components. And what it means is that you can just use this object, put it in your CSS, and you don't have to think, what's my body class? Do I need to make some other funny conditions or mix-ins? It's so declarative and so clean. And as I said, the theme is really simple. So there's really no magic there that you have to worry about wondering how you're going to debug it, right? So looking here, you have simply the exact same code, the exact same button that just says, I'm primary. Use the primary color, and it doesn't have to think about what it's going to look like. So this solves our theming problem, which makes things really, really easy. But I mentioned before that we're not just working in a React universe, right? In fact, the world is a bit more complicated than that, especially when you're thinking about a design system where actually you do want to cover everything. It's not just about saying, oh, my React apps are pretty, but my emails are ugly, and my landing pages are ugly. So you don't really pick and choose. So here you can see, okay, we have some stuff using React, like our Next.js stuff. But we also have third-party applications. For example, Salesforce. Is Salesforce ever going to use React? I don't think so. They've invested quite a bit in their own programming language, if you are fortunate enough to know that. And yeah, so our life is really not so simple that we can just say, oh, I'm going to stick a theme provider on everything and that's that. Now, if we were using Sass, I would say life would be pretty simple. I could probably do this in Bash, right? I could just collect all of my Sass files, put in my variables, done, right? You could do this in Gulp if you wanted to. But what makes things a little bit more complicated is that when you're using CSS and JS, the computed CSS depends not just on the theme, but also the parameters that are provided. So if you think about this in like my attempt at a math equation, you have to multiply however many themes you have by every possible combination of parameters in order to find out what are all of the CSS styles I need to put into, say, an external styles sheet. And this is where Node comes in, right? A lot of things can be solved with the Node script, and this is one of them. So how we do this. So each of our modifier classes is essentially labeled using a functionality in Emotion where you can basically set it up that each CSS class is going to have the modifier behind, like EM style, and then at the end you end up with something that the class names that can be kind of like altered a little bit so that they look nice. And how the node script itself works is that you basically render all of these components in memory. Each of the computed CSS rules is put into the emotion internal cache, and then you can kind of like suck these out, change a few lines like simple search and replace, and you end up with really nicely namespaced BEM style classes, and you didn't have to really write them, right? You still get this nice theming functionality. So what does this mean? This means that in React apps, you can just pass in your normal prop, selected tag, but in plain CSS, you end up with actually quite clean CSS classes, which follow a standard and can be easily replicated. So this is kind of like getting the best of both worlds. So I have modern CSS, and it's really easy to do theming for multiple products. And I can also style older apps, legacy apps. I can kind of mix and match things if I need to, and this leaves me a lot of flexibility. So finally, I'm going to talk about the processes. So this is all really great when you have a dedicated team, but how does it work when you have a lot of different people who are going to be needing changes in this design system? Because we don't want the design system to become a bottleneck for a lot of other teams simply waiting for us to implement something. They should be able to do it themselves. And how we did this is our very basic introductory version of our documentation, which is implemented in Gatsby. And basically, we're using a plugin that will help us to pull the doc types from the components themselves. And we have all of these doc types provided when you create a new component, because we have like a super simple bash script that people can use to create new components that are going to be automatically compatible with the documentation. And this is pretty nice because it means that actually it's easier to create documentation compliant components than to actually manually touch all of these files yourself and open them and everything like that. So it means that, yeah, it's going to be easy for people to write well-documented components. And finally, when it comes to regression testing, so probably a lot of people here are familiar with snapshot testing. Yeah, by now, I guess it's pretty standard. But specifically when it comes to testing the results of static CSS extraction, this is really critical because since our CSS has to be computed and we want to rely on what the result is going to be, and we need to be aware of what kind of changes are going to happen because it's not so transparent when you're writing programming code inside of your CSS. What we can do is use a serializer for Jest that is basically going to take all of our computed CSS and format them in a really nice way. And the result is that you can really easily see how your CSS classes change, how the properties change, and understand whether these are going to be anticipated changes. So as I said, for us, this is really critical because if the computed classes change, we need to be aware because we don't want to introduce breaking changes for our CSS-only friends. So in a nutshell, let's see where we've been, and then I'm going to talk about what we built. So we began with the use case, this currency input, and what happens when you have developers working on a complex project with no single source of truth. We also talked about what a design system is and why it's scalable by nature and how it could probably help you if you're having some of these same problems. And we also talked about some of the challenges that we had. The fact that the team is growing, we have to onboard a lot of people. The fact that our product offering is becoming more complex, but that we still have a tech stack from up to 5 years ago, and we need to make sure they're also included in our design system. And finally, we talked about how multiple teams are able to use these tools to work in parallel without breaking things for each other, because that would probably cause quite a bit of tension, right, if you don't have some automated ways to make sure this doesn't happen. So now I'm going to show you what's the result of all this. But before that, where we came from. Yeah, so it's pretty common that when you create a design system, you start by doing what's called an audit. And it's as scary as it sounds. So what you do is you basically go into every dusty corner of every app that you have that might want to be covered by the design system one day, and you try to find every use case that you can, right? Because you don't want to develop the one button to rule them all that actually can't rule them all because it was fundamentally flawed from the beginning. So here's just a small collection of all the buttons we collected. So yeah, you can see there's some nice bootstrap, some misaligned buttons, that's also nice, you know, keeps things spicy. And yeah, you can see we have pagination, we have things for appending files, you have sharing buttons. I mean, you can really discover quite a bit of functionality here. And for me, what's really significant about this slide and what we discovered is that all of these buttons, besides the bootstrap ones, they were thought about a lot. So somebody planned them, a designer has them in a sketch file somewhere. They probably labored over whether it would be a 2-pixel or a 3-pixel radius. And then a developer went and implemented them very carefully in CSS. And you can just look at this slide and imagine like how many hours of work it took to make this like totally incomplete mess of buttons. Wow, yeah, it's crazy. And obviously this scales up, right? So we've been through a number of redesigns in the last few years. I've been with the company for 3.5 years, and in that time we have had 3 different shades of blue as our brand color. So yeah, you can kind of see that these things get left behind. So when you do a redesign thinking app by app and you have a bunch of apps, well, obviously this isn't going to work, right? Well, it's obvious until 3 years later when you realize it was obvious, right? So yeah, you can see we have our like shiny like Next.js website. We have a recently designed support center, but we also have this, which is the result of our CSS only library. You can see that CSS only doesn't result in things being aligned with each other. So where did we go? Actually, how did we get out of this mess? We created our design system, which we called Circuit. And the idea behind this is that just like any electronic circuit, our design system consists of small parts that work together to channel energy into something bigger than itself. So we started with thinking about headings and colors and spacings, all of the basic stuff. We followed the atomic design principles. And we named our types after memory sizes because extra large became difficult to remember. And we also developed a new set of buttons, obviously, which now handles the different cases that we had and are a lot more consistent, and they exist in just one place. So very last thing I want to show you is just one screen that we have redesigned using the design system. So this screen is the virtual terminal screen. You can see the final currency input, which doesn't look like either of the other two. And what's really cool about this is that every single one of the unique elements on this page is coming from our design system. So when you implement this, there is essentially, and perhaps even literally, no custom CSS. And I don't know about you, but I love that. So you really get to focus on how it works, as opposed to spending a lot of your time battling browser CSS problems. Someone already did that. And yeah, it's super efficient. I can say for myself participating in the redesign that I can do things at a totally different speed now, thanks to having implemented this design system. And finally, why I am here, or was invited to talk here, is that it's open source. So you can totally look at the code. Maybe it will be inspiring for your design system. We looked at a ton of open source projects to get inspiration and kind of combine the different approaches to find one that works for us. So yeah, feel free to check it out. And finally, thank you for your time, and I hope you enjoyed.